Hey, this is Mr. Ward, and this is the PreAlgebra exit ticket 29.3 video key. And so here we go. Is this a right triangle, an acute triangle, or an obtuse triangle? Remember, an acute triangle would have all angles that are less than 90 degrees. An obtuse triangle would have one that is more than 90. The others would have to be acute because that one that's more than 90 would have used up too much space. So you would have less than 90 left to work with for the other two. A right triangle, of course, has one angle that's a right angle. And if you can say that the squares of the short sides could be added together to get the square of the long side, it would be a right triangle. So let's test that out. So first of all, we're just going to test that out. So the short sides are 7 and 5. So 7 squared, pardon me, plus 5 squared equals what? It equals 49 plus 25, which is going to equal 74. And then we'll take a look at the long side. 8 squared equals 64. And of course, 74 is bigger than 64. So definitely not a right triangle. Now, but is it obtuse or is it acute? So I often have a hard time remembering which one is which. So a good thing to test would be the ultimate easy acute triangle. So an ultimate easy acute triangle would be an equilateral triangle. We'll use one that has sides that are all 1. So this angle and all the other angles are 60 degrees. So they're all acute angles. So 60 degrees, 60 degrees, 60 degrees. 1, 1, and 1. Now, which one is the long side? Well, it doesn't matter. So I'll just pick this one to be the C part of that, and these two I will treat as the A and the B. So I'm going to say 1 squared plus 1 squared. If you're ever having a hard time remembering this, just do this. So that's just going to be 1 plus 1, or 2. And 2 is definitely going to be bigger than 1 squared. So we got something that's bigger than our sort of stand-in for the longest side, our hypotenuse. Hypotenuse means longest side, by the way. It's not distinct to right triangles. But the hypotenuse that we're creating, it's not actually longer because it's all the same. We square that, we're going to get just 1. So our other two sides, their squares, add up to something more than the square on this side, which is in fact what we got here. So if this is acute, then this one is also acute. Okay, because the squares of the short sides add up to more than the square of the long side. We have an acute triangle. Okay, and I'm going to just lay that out. So when a squared plus b squared is greater than c squared, triangle is acute. Now, of course, if a squared plus b squared were less than, that's not squared, were less than c squared, triangle would be obtuse. Okay, when they're equal, it's a right triangle. So if a squared plus b squared equals c squared, triangle is right. And there you go. Well, let's take a look at the next question. The next question asks you to figure out how long x is. And you want to do this, what I'd love you to do it is without a calculator and without decimals, putting it exactly. And when I say putting something exactly, if it's a neat and tidy square root, find the neat and tidy square root. If it's not a neat and tidy square root, leave it in the square root symbol. So the square root of 2, for example, is 1.41, blah, 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 forever, not having a repeating pattern. But you could write it exactly like this. You just say the square root of 2, and you're done. Okay, let me erase that for now because I'm going to need that space. So let's start off with here. the first set, and I prefer to do this by pen, even though it's a big fat pen. 1 and 1 are my short sides, and I'm going to have to start off by ultimately I need this side length, but the nice thing about this side length, and I need this side length in order to use the Pythagorean theorem to find out this one, but this side length is the hypotenuse for this triangle, and this side length is the hypotenuse for this triangle, and this side length is a hypotenuse for this 1 by 1 triangle, which happens to be a 45, 45, 90 isosceles triangles, isosceles because these two sides are the same. So we can easily find out this one, and then we can build the bear all the way up to that one. So this first set is going to be 1 squared plus 1 squared. And that's going to equal 1 plus 1, or 2. Now, to find out what this is, we got to get the square root. So I'm going to get the square root of both sides to keep that an equation. And this answer is the square root of 2. So that is the square root of 2. Now, I'm going to need this one. I'm going to have to square the square root of 2. The square root of 2 squared. And then I'm going to have to square 1 plus 1 squared. And that's just going to end up being 2, square root of 2 squared is 2, plus 1, which is 3. So I'm going to get the square root of both sides, and that'll just be the square root of 3. Now I'm doing it up here instead of by typing because it's a little harder to write a square root. Now, here, I'm going to get the square root of 3 squared. I have to square that, plus 1 squared. And then that's going to equal 3 plus 1, which will be 4. And I'll get the square root of both sides. And that'll just be 2. So I'm going to write it here as the square root of 4, because there's a pattern to see. And then I'm also going to write it as 2. Now, there's also a negative square root of 4, negative 2, but since we're dealing with a side length, we're going to discard that as extraneous and just deal with the positive version. Now, I've got my final step. I'm going to say 2 squared plus 1 squared, which is going to be 4 plus 1, or 5. And then I'll get the square root of both sides to find out what that is. So square root of 5 is x. And so 1, 2, 3, 4, 5. Wonder if you know what the next side would be if I built one more triangle like this. How long would that be? Like that, right? That one would be the square root of... What did I do here? Hang on a second. My goodness, Mr. Ward. I tricked myself. My brain was on to the next thing. Square root of 5 here, and square root of 6 and 7 and 8 and 9. And this is, in fact, the spiral of Herodotus. I hope that was helpful.